Welcome to the Unit 3 review key video. I'm going to go through all these questions and hopefully that helps you study for the test on Friday. First step in these types of questions for graphing rational equations is factor. Okay, so we have 4x minus 8. We can take a 4 out, left over with x minus 2. On the bottom, we have x squared plus 6 plus x minus 6. If we factor this, we're going to get x plus 3. No, I lied. Yes. And x minus 2. Okay. We can cross out the x minus 2s. We're going to get back to those later. So our equation we're going to be using is going to be 4 over x plus 3. All right, now getting into the pieces. To find the y-intercept, we put zeros in for the x's. We're going to get 4 over 0 plus 3. Which just gives us 4 over 3. So we'll write this as a point, 0, 4 over 3. We'll put those things on a little bit later on the graph. For the x-intercept, we take the numerator of 4 and set it equal to 0. Well, in this case, 4 equaling 0 is not a true statement, which means there is no x-intercept. For your vertical asymptote, we take our denominator of our fraction, x plus 3, set it equal to 0 and solve for x, which gives us an equation of x equals negative 3. For the horizontal asymptote, we take the coefficients of the top and the bottom. In this case, that would be 4 is the only thing left on the top, and the x is the first of the bottom. If we have something like this, we're putting really, really big numbers in for x, and 4 divided by 1,000,000,000,000 is going to be close to y equals 0. All right, and then next we have to deal with the wholes. So the wholes is based off of what we canceled out. And we canceled out the x minus 2. We set that equals 0, we get x equals 2. All right, that's our x value of our whole, 2. To find out the y value, we're putting that number back into our equation. So we have 4 over 2 plus 3, which gives us 4 over 5. And that is the whole. Now, with those 5 things done, we can start plotting those points and asymptotes to figure out whether or not we have to do the sign analysis. So your your y-intercept is 0, 4 over 3, which is going to be a little bit over 1. There's your y-intercept. Your x-intercept, there is none, so we don't have to put a point for that. Your vertical asymptote is at x equals negative 3, so that is right here. Your horizontal asymptote is y equals 0. Let's erase that stray mark because it's bothering me. All right, your whole is at 2, 4 over 5. So 2, 4 over 5 is going to be here. That's an ugly hole. There we go, that's better. All right, and then we're out of stuff. Which means we do have to do a sign analysis because all this stuff over here, there is no point. So we got to find a point that's over on that side. So we can pick any x value that we want on the left side of our vertical asymptote. Let's pick negative 5. Why? Because I said so. You can pick anything you want. You can pick negative 4, negative 5, all the way to negative 10. It doesn't really make a difference. It has to be to the left of the vertical asymptote, and then still on the graph would be helpful. So I'm putting negative 5 as my x term. To find out what the y value is, I put that x term into our equation. So we have 4 over negative 5 plus 3, which gives me 4 over negative 2, which is just negative 2. So negative 5, negative 2 is another point for our graph. Right? And now that we have points on both sides of the asymptotes, we can just graph using the asymptotes as our borders. So there's the first one. Second part, making sure that your graph does not go through the hole, it just goes around it. And there's your first graph. So that's all the stuff that we have for it. Okay, the next one. Again, we have to factor. So we factor this. Two numbers that multiply to give you -4 but add up to give you +3 are going to be x plus 4 and x minus 1. On the bottom, two numbers that multiply to give you +8 and add up to give you 6 are x plus 4 and x plus 2. Since the x plus 4s are both on the top and the bottom, we can cancel those out. We're going to be dealing with x minus 1 over x plus 2. So that's the equation we're going to use for the finding all this stuff on the right. For your y-intercept, putting zeros in for the x's, you'll get 0 minus 1 over 0 plus 2. Gives you a y-intercept of -1/2. Again, putting it as a point is important. For the x-intercept, you're going to take the numerator of x minus 1, set it equal to 0, and solve. So your x-intercept will be 1, 0. So we solved for x equals 1. Your vertical asymptote is going to be the denominator. X plus 2 is equal to 0. When you solve that, you'll get your equation of x equals -2. Your horizontal asymptote is the coefficients, the leading coefficients of the numerator and the denominator. In this case, that is x and x. And x divided by x is 1. So y equals 1 will be your horizontal asymptote. And then we can put down the whole. The whole, we cancel out x plus 4. Set that equal to 0 and solve. So x equals -4. That is the x value of your whole. Now we need to find out the y component by putting that number back into our equation. So -4 minus 1 over -4 plus 2 gives us -5 over -3. No, sorry, -5 over -2. Negative over negative is a positive. So positive 5 over 2. I'll get it. All right. We have those 5 things down. Now we can start figuring out where all those things belong on your graph. So the y-intercept is 0, -1/2. So that's going to go right here. Your x-intercept is at 1, 0. That goes right there. Your vertical asymptote is x equals -2. So we're going to put that right here. Remember, vertical goes up and down, which means horizontal goes left and right. Horizontal asymptote is at y equals 1. Your whole is at -4, 5 over 2. So that's 5 over 2 is 2.5. So -4 and 2.5, which is going to be right about here, is the whole. So, looking at our graph and what we have available to us with points on either side of the vertical asymptote, we don't need to do the sign analysis because we have enough points to be able to graph this. So we're going to graph using the asymptotes as our boundaries and making sure that we don't go through the hole. There we go. There's your graph with all the stuff about it. All right, number 9. So again, we have to factor the top. 3x plus 9 has a 3 in both terms. So we're going to take that out. We have x plus 3 left over. On the bottom, two numbers that multiply to give you 6 but add up to give you 5 would be x plus 3 and x plus 2. Crossing out the x plus 3s, we're going to be left with 3 over x plus 2. All right, for your y-intercept, you put zeros in for the x's. 3 over 0 plus 2 gives you a y-intercept of 3 over 2. All right, again, please make sure your y and x-intercepts are both written down as points. For your x-intercept, you take the numerator, in this case 3, set it equal to 0. That is not actually a true statement, so that means there is no x-intercept. Your vertical asymptote, you take the denominator, x plus 2, set it equal to 0. Solve for x. X equals -2 is your vertical asymptote. Your horizontal asymptote is found using the leading coefficients of the numerator and the denominator, in this case 3 and x. Just like in the first question, if you put a really big number in for x, like a trillion, 3 divided by a trillion, it's going to be close to 0. Now we did cancel something else, so we will have a whole. We canceled out x plus 3. Set it equal to 0 and solve for x. So our x component of your whole is going to be negative 3. We put that into our equation, 3 over negative 3 plus 2 will give you 3 over negative 1, which is negative 3. So we use these 5 things to graph and then see if we need a sign analysis. 0, 3 over 2, which is 1.5. It goes right there. There is no x-intercept. The vertical asymptote is negative 2. The y-intercept, or sorry, the horizontal asymptote is y equals 0. And our hole is at negative 3, negative 3. So right, oh, I don't like that. Negative 3 and negative 3, right there. So again, we have a point on either side of the vertical asymptote, so we do not need a sign analysis. Gosh, that's ugly. There we go. So we can just graph our lines using the asymptotes as boundaries and making sure that we don't go through the hole. We have here nice sweeping lines. There we go. That is the graph with the information for the third question. Okay, composite functions. Ooh, love it. First one, we're putting negative 7 in for the f function. The f function is 2 times x, which we're replacing as negative 7, plus 1. So 2 times negative 7 is negative 14. Negative 14 plus 1 is negative 13. That is it. Number 11, g of x plus 1. So we're going to put 3. We're going to replace this x with x plus 1. So we have x plus 1, and then it's going to be squared because that's still part of our original function. We should multiply this all out. If you have x plus 1 squared, it will be x plus 1 times x plus 1, and multiplying it by 3 at the end. So x times x is x squared. X times x, or 1x, sorry, x times 1 is x. 1 times x is x. And 1 times 1 is 1. This is still being multiplied by 3, which we'll do in just a moment as we combine all the like terms. So 3 times x squared is 3x squared. X plus x is 2x times 3 is going to give me 6x. And 3 times 1 is 3. That would be the answer for 11. All right, number 12, G and H. So we're putting 6 into both G and H. So for G, we have 3 times 6 squared plus H is x squared. Sorry. The x is being replaced by 6 squared plus 2 times 6. Now I'm going to put both of these terms, both of these functions rather, in parentheses, just because it's a good habit. It will solve many of the issues that we're having by doing the order of operations wrong. So let's do that. So if we get this out, we got 6 squared is 36 times 3 is 108 plus 6 squared is 36 plus 2 times 6 is 12 gives you 48. 48 plus 108 is 156. All right, number 13. We got g minus h. We're putting x in for that. So the g function is 3x squared. All right, we're putting x in for x, so that doesn't change the function at all. All right, I'm going to put that in parentheses, though, just because it'll save me some hassle later. Then the h function is going to be x squared plus 2x. I'm going to put that whole thing in parentheses as well. So now we're distributing that negative times both terms in that second parentheses. So we have 3x squared minus x squared minus 2x. Then we have to combine the like terms. Those first two things are like terms. So 3 minus 1 is 2x squared minus 2x. And that is our answer. (14). This is our first of our composite functions. All right, we're doing how this works. So you're putting -1 into the h function, figuring out the answer, and then that answer goes into the f function. So let's do the h value first. So you have x squared plus 2x. So we're putting -1 in for the x's. So that's the h function. We're putting -1 in for both x's. Now we just simplify. -1 squared is +1. And 2 times -1 is -2. And 1 minus 2 is -1. Now we're going to put this value into the f function. The f function is 2 times x plus 1. So 2 times, we're putting -1 in for that x. So 2 times -1 is -2. -2 plus 1 is -1. So that is the answer, -1. Okay. 15. All right. This is the same kind of notation. It's just a different version of the composite notation we just did in number 14. So we're putting 0 in for the f, and whatever answer we get from that, we're going to put it back into the f function again. So we have 2 times 0 plus 1. So 2 times 0 is 0 plus 1 is 1. Okay, now we're putting this number back into the f function one more time. So now we have 2 times 1 plus 1. 2 times 1 is 1 plus 1. Sorry, 2 times 1 is 2 plus 1 is 3. Okay. H. So we're putting -3 into the h function, and whatever we get out of that, we're putting back into the h function one more time. Okay, so we have x squared plus 2x. So we have x squared, so it's going to be -3 squared plus 2 times -3. That's what our function is. So we're going to figure out what this answer is, and whatever that is, we're going to put back into the h function one more time. So -3 squared is 9. 2 times -3 is -6, which gives us +3. All right, we're going to put this number back into the h function again. This time it's going to be 3 being squared, not -3, plus 2 times +3. All right, 3 squared is 9. 2 times 3 is 6. And 9 plus 6 is 15. So h of 10, so h of 10. So we have 10 squared plus 2 times 10. I'm going to put this all in parentheses. Minus f of -1, so f is 2x plus 1. So 2 times x, which in this case is going to be replaced by -1, plus 1, big parentheses. All right. Now inside the first set of parentheses, we can do 10 squared, which is 100, plus 2 times 10, which is 20. So 100 plus 20 is 120. Minus 2 times -1 is -1. 2 times -1 is -2. My goodness. -2 plus 1 is -1. -1 times 1, -1. Gives +1, so we get 121 total for number 17. Lastly, I'm putting g, x into g, and g into h. Okay, so the g function is 3x squared, and the h function is x squared plus 2x. So I'm putting 3x squared into both x's of the h function. So I'm going to have this is going to be squared plus 2 times 3x squared. Okay. In this case, I have to square both terms inside the parentheses. So 3 squared is 9. That's ugly. X squared times x squared squared is x to the 4th. You're multiplying the two exponents together. Plus 2 times 3 is 6x squared. And there's your answer. All right, some logarithms. So we want to change this logarithm into an exponential function and solve for x. So we're going to smash the log, which brings the base of the log over here. So we have x is equal to 4 squared. So 4 squared is 16. So x equals 16. I'm going to turn this into a log. So this was the base of your exponent, which means it's the base of your log. 125 goes here, equals x. All right. Here we're condensing the log into one expression. All right. Because it's a plus, we're multiplying our terms. So you have log base 4, and then 5. The 3 becomes an exponent on the x, x to the third. There's that one. Number 23, we're expanding. So there are two terms here. There's the 6 and the y squared. So we have log base x of 6. Because we're multiplying 6 and y squared, it's going to be plus. The 2, the squared on the y becomes a coefficient in front of the log of y. All right. These are natural logs, but they work the same. Because we have a minus sign, we're dividing, so we have natural log of 5 over 3. And then here, we're expanding. This is going to have 3 parts because it's 4 times x. So we're going to have natural log of 4 plus the natural log of x. And we're dividing the w, so that's going to be a minus natural log of w. For 26, this is a combination of the two of the things we did above. We're combining logs, and then we're solving using logarithmic equations to turn into an exponential, and then solving for x. So we have 2 logs here. Since we're adding, we're going to combine them, and the 5 and the 20 will multiply. So we have log of 5 times 20 equals x. All right, so 5 times 20 is 125. Now, the other thing that we don't have here is there's no base for your log. But we talked about this. The base for a log that doesn't have a base is 10. So 5 times 120, sorry, 5 times 20 is 100 equals x. If we smash the log, the base goes over to this side. So we have 10 to the x power equals 100. And what do we do? What exponent makes 10 into 100? X equals 2. All right. We have a exponential equation with like bases. How do we turn the 16 into a 4 using exponents? We change that to be 4 squared. X plus 1 equals 4, x minus 7. All right, before we can get rid of the 4s, we have to multiply the 2 times both terms of our other exponent. So 2x, sorry, 4, then 2x plus 2 equals 4, x minus 7. Now that we have the exponents all in one level, we can cross out the 4s. We get 2x plus 2 equals x minus 7, and then solve that equation. Subtract the x from both sides. Subtract the 2 from both sides. You're going to get x is equal to negative 9. Here, the bases are already the same, so we can just get rid of them. So we have 3x plus 4 equals 4x minus 6. Subtracting 4x, subtracting 4. So we get negative x equals negative 10. Divide both sides by negative 1, and you get x equals 10. Here, again, you can make these into like bases. So you're going to have 3 to the 2x power. 27 can be made into a 3 if you cube it. Oops, not square it, but cube it to the 4th. All right, we're going to multiply the two exponents together. 3 times 4 is 12, so we're going to get 3 to the 2x equals 3 to the 12th. Now that the bases are the same and the exponents on the same level, we get 2x equals 12. By canceling out the bases, x will equal 6. All right. The last grouping, last 4 questions are using logs to solve this. All right, so we're going to change this problem into x times log of 3 equals log of 8. Okay, to do this, we have to divide both sides by log of 3. So that will cancel out, and you'll get x is equal to, and I'm going to put this on the calculator log of 8 over log of 3. Let's put it in here. So we have log of 8 divided by, and I'm going to put the whole thing in the bottom, in parentheses, log of 3. Gives me 1.89. Oh, hold on. We're not going to do that anymore. We're going to do it on a calculator off screen. 1.89. Or you know what we'll do? That's what we'll do. Okay. It's a better idea. All right, number 31 here. Same idea. We're going to have x log of 4 equals 2 log of 7. We're going to divide both sides by log of 4. So when we put this in the calculator, we're going to have, I'm going to put the top in parentheses as well. So we got 2 log of 7 divided by log of 4. So you get 2.8, or I'm going to round up to 1. So x will equal 2.81. All right. Next, now they get a little more complicated. So we're going to have 3x log of 5 equals x minus 6 log of 4. In this case, we have to have some manipulation of this because we have 2 x's in our equation. So I'm going to distribute the log of 4 on the right-hand side to both terms in our parentheses, the x and the negative 6. So I have 3x log of 5 equals x log of 4 minus 6 log of 4. Okay. I'm going to subtract the x log of 4 to the other side, so I get 3x log of 5 minus x log of 4 equals negative 6 log of 4. Okay, now that I have all the x's on one side, I can take the greatest common factor of x out. I'll be left with 3 log of 5 minus log of 4 equals negative 6 log of 4. I can then divide all of this stuff in parentheses to the right side. Sorry, I'm just going to write it once because, well, I am. 3 log of 5 minus log of 4. Okay. So I'm dividing all that stuff so it goes away. So now let's put in the calculator. I'm going to put the whole thing in parentheses. So I start with this. I got negative 6 log of 4, and I close the parentheses, divided by, the whole bottom part's got to be in parentheses, so we have 3 log of 5 minus log of 4, close that parentheses, and I'm going to get negative 2.4. 2. Round up for the hundredths. All right. One more. So again, we're going to have x plus 1 in parentheses, log of 8 equals the log of 20. Now this one you can do a little bit of an easier way. You don't have to distribute the log to both terms because there's only one x. So what I'm going to do here is I'm going to divide both sides by log of 8 first. Those two go away. Then I have x plus 1 equals log of 20 over log of 8. And I'm going to subtract 1. So if I put this into my calculator, very carefully, I'll find out what x is. So I'm going to do this again. Here we go. So we have, put top in parentheses just to be safe, log of 20 divided by the log of 8. Oh, hold on. Put that there. Okay, and then on the outside, I'm going to put minus 1. So I get 0.44. And there we go. That is the end of the review sheet. If you have questions, please make sure you ask in class before we get to the test on Friday.